One of the biggest questions I had about the new multi-frame generation mode for DLSS 4 is what will be the additional latency penalty for enabling the extra generated frames. And I was really excited today to see that Digital Foundry has been given some testing access. They said they had about 5.5 hours with an RTX 4080 to play around with it. And so now we get some more independent results than what we're getting directly from NVIDIA. Although again, keep in mind that anything being given out at this point in time would be, I would imagine, more supervised than by NVIDIA rather than just a free, here's a 5080, do whatever you want with it, that type of thing. So I think there's some limits probably on what can be told here, but it's still more independent than just looking at, NVIDIA's marketing graphs. Now, with that in mind, let's talk a little bit about the DLSS update and get into what we're able to get out of some of this more independent testing and just additional footage compared to what, NVIDIA gave us. And NVIDIA gave us slides like this. Now, this slide is, it's showing the frame rate advantages of kicking on the DLSS 4 multi-frame generation mode, and it does show us some numbers of latency. But they're also going to be trying to hide things. So to be clear, this is the one from NVIDIA rather than the footage from Digital Foundry. It's like a 6-second clip with nothing really moving. So it's going to be extremely difficult to notice any image quality issues with the generated frames because there's hardly any movement. But you do get to see the frame rate numbers, and look, they go up a lot. But there's also these latency numbers here, and I was a little curious about this because, okay, first of all, DLSS off going to DLSS 2, and what they mean by that is super resolution. So you're not using generated frames, you're just rendering the game at a lower internal resolution in order to be able to just generate frames quicker, and then you use the DLSS CNN model to then upscale the image. That's what we're seeing here. And notice that the latency decreases massively when the frame rate increases. This means that in addition to getting more motion fluidity from the higher frame rate, you're also getting more responsiveness. The game is more responsive to your controls. Your mouse movements are more instantly captured on the screen. This can help with things like aiming, just dodging, just the game just feeling responsive to you. And both of these things are important things about what we think about high refresh rate gameplay. The increase in responsiveness and the increase in motion fluidity. Now, what we noticed with the introduction of DLSS 3 with the 40 series is that enabling frame generation did increase motion fluidity. Notice we're going from 70 frames per second to 142 frames per second. So you will see way more frames on your screen, which means that you are going to perceive much more fluid motion on your screen. However, notice there's not a large decrease in latency. However, what I was surprised by here in NVIDIA's footage is that they're showing any decrease in latency because what I would actually expect here is an increase in latency. The game would become less responsive, and that's what independent testing has measured with DLSS 3. And I think the only possible explanation for this is they're probably choosing not to use NVIDIA's reflex technology for latency reduction when they have DLSS 2 enabled in this slide, and they're probably choosing to enable reflex when they're enabling frame generation. It does get enabled by default. However, there's no reason why you couldn't also turn on reflex here and here. So they're using that choice to mask some of the latency penalty of enabling frame generation. Then they kick on DLSS 4, which enables multi-frame generation. And it also has changes to the underlying super resolution model and the way the frames are generated. And they're getting this larger increase in frame rate and with only a small increase in the latency. But these are in the moment numbers rather than, I believe, averages. So if I freeze this on a slightly different screen, those differences will be, slightly different. So in other words, there's a bit of a problem that's been introduced now that we have to deal with frame generation, and that's going to be potentially even more important to point out now that we're moving into the world of multi-frame generation. And so that's where sorry if I blind you with the light colored background here, but in other words, traditionally we've used frames per second to measure how good a graphics card is. Because as frame rate increases, both main things that you would want when playing a video game also increase. The responsiveness, because that as you reduce latency, you increase the responsiveness, and the motion fluidity, how it looks visually smooth. But now that we move into the world of increasing frame rate via the means of frame generation, as frame rate increases, responsiveness tends to take a small decrease rather than an increase, but motion fluidity increases, however, with the other asterisks of, but it can also add in visual artifacts. In other words, these generated frames often don't look as good as an actual frame. They have some errors that are displayed very briefly and often are minor, and the higher your base frame rate is, the less error you tend to get, but still, it can cause some issues. It's at a point with me where when playing on, I usually use a 4090 when gaming at home because I have one, so of course I'm gonna use it. What I've noticed is in some games, I'll always try frame generation when it's available, but I will oftentimes end up turning it off. Oftentimes I'll end up leaving it on. It's kind of hit or miss depending on the game based on how much the visual artifacts are bugging me in that particular game. Some games I find them more bothersome, some games I don't notice them at all. So there's this little bit of a trade-off to where is the increase in motion fluidity worth the increase to artifacts and the small decrease to responsiveness. So those were the main things I wanted to get a better feel for with DLSS 4. And since review samples haven't shipped yet, we have to rely on people who are getting some special early access, like Digital Foundry, to get us some more of these details. And so all my sources will be in the video description today, and I highly encourage you to watch this entire Digital Foundry video to get much more information on their testing that they did than what I'm going to get into specifically here. But I am going to highlight a few things available through their testing. First of all, a more accurate, I guess, comparison of the latency. First of all, this is a PC latency graph over time, and then they have now averaged those results over the duration of what they said was about a 2.5-minute test run. Now, this is still DLSS 4 frame generation, but it's in its ×2 mode compared to its ×3 mode and its ×4 mode. So the ×2 mode is the most similar to what we would be familiar with from DLSS 3 frame generation, although the actual model it's using and the way it does the optical flow analysis has moved to an AI model and is supposedly a bit more performant and supposedly a bit more accurate as well. Now, to get an idea of the differences here, DLSS 3 frame generation, and this would also kind of be the case for DLSS 4 frame generation in its ×2 mode, renders one frame and then generates the next frame. And what they're not showing you in this slide is they're also using information from the next rendered frame. So they use 2 rendered frames and decide what probably happened in between. And that's why you get a little bit of a latency penalty, is because it needs some answers from the next actual, more traditionally rendered frame in order to inform the results of what's happening in between. Now, what we're getting in the multi-frame gen mode is you could increase to, you could still just be at the ×2 mode where you have 1 frame in between the next real frame, or you could have another generated frame and then a real frame, or you could have another generated frame and then a real frame. And for now, that's going to be the limit. You'd get your next real frame here, and this would be the DLSS 4 in its ×4 mode. So the thought process here then, though, is, so to generate these extra frames, what sort of additional latency penalty, if there is any, comes into play? And then also, what sort of image quality artifacts are we going to have? Because previously, you would have 1 generated frame, and then you get back to your next more traditionally rendered frame, which would not have those artifacts from the frame generation. So every other frame would flip back to an artifact-free frame after your briefly displayed potentially artifact-filled frame, right? So the issue here is if we're going to have 1 artifact-free frame followed by 3 potentially artifact-filled frames, what kind of effect does that end up having on image quality? Now, if the model's good enough, maybe there aren't many artifacts and it's going to be absolutely fine. But those were the questions I had about the DLSS 4. So here we have their results for the latency testing, and we can see that there is an additional latency penalty, although it's not massive. Going from the ×2 frame gen mode to the ×3 frame gen mode looks like an increase of, a little over 4 milliseconds additionally. And then going from there to the ×4 mode is less than 2 additional milliseconds on average. And going from the ×2 mode all the way to the ×4 mode, you're seeing a little over a 6 millisecond latency increase. So it doesn't appear to be a lot of extra latency compared to the ×2 mode that we were probably already used to with DLSS 3 frame generation. So it doesn't look like from a latency penalty there's going to be a massive difference here. I think you still wouldn't be wanting to use this in competitive games where the responsiveness is crucial. But if you're playing in single-player games, I don't think that increase of just single-digit milliseconds is going to be make it or break it if you were already at a decent base frame rate. So I think this is pretty good news from the latency standpoint, although it is continuing the trend of the more generated frames you get, the more latency penalty you get as well. And again, you're not getting increased responsiveness as you get that increased frame rate. That being said, the actual frame rate numbers do seem to be pretty remarkable. Now, what they're showing here is the RT overdrive mode on the RTX 5080 at just a native 4K resolution with no upscaling. Now here, they're showing going all the way to performance mode upscaling and ×2 frame gen. So this isn't just the effect of frame gen, it's the effect of upscaling and frame gen compounding. But then you've got your ×3 mode and your ×4 mode. So altogether, it does look like Digital Foundry's testing is confirming that there is a massive increase to frame rate, and your frame rates from your ×2 mode to your ×4 mode is increasing pretty significantly as well. So for that little increase to latency, it does indeed look like you are getting a lot more frames per second. That should be a big improvement to motion fluidity. So if I, at the risk of blinding you again, kind of pop back over to this chart, if we think about this frame gen stuff compared to like DLSS 3 frame generation, and now look at DLSS 4 frame generation, it does indeed look like you are going to get an even larger increase to motion fluidity with the DLSS 4 frame gen. And the loss to responsiveness doesn't look like it's going to be massive. Based on this testing, it's just one game so far, all of that. Then that leaves this big asterisks of, okay, but what about the added artifacts? And that's where I have my largest doubts about the technology. Because like I said, one artifact-free frame, or at least not any artifacts you have aren't from the frame generation, maybe it's from other upscaling techniques or whatever, but no frame gen artifacts, then potentially 3 artifact-filled frames followed by your next non-artifact frame. So you now have more frames with potential frame gen artifacts than without. And that's a pretty big contrast to just flipping one and then the other. So if the model's good enough, maybe it's totally fine, right? Could be totally fine. But for my personal use of frame generation, like I've already said, even with just normal DLSS 3 frame generation, the artifacts have been the bigger issue, where in some games I think it's great, I keep it turned on, and in other games it kind of bugs me. Like I was just playing Silent Hill 2 Remake, I ended up turning it off. I played with it on for a while, and there was just too much artifacting that it kind of bugged me, I ended up turning it back off, right? But I've played other games like Plague Tale Requiem where I left it on, I thought it was great. Anyway, so what do we get out of this video? Well, looking for the image quality artifacts from a YouTube video is going to be our hardest job here. And in this Digital Foundry video, they talk about the challenges of trying to show what this looks like on a YouTube video. The thing you need to understand, and that a lot of people don't realize when you're watching a YouTube video, is that watching a YouTube video of gameplay is very different than watching that same gameplay on your actual monitor if you're playing the game yourself, especially if you have a variable refresh rate display, which I think by this point most people do. That's G-Sync, V-Sync, not V-Sync, G-Sync and FreeSync, that type of thing. YouTube videos are locked to 60 frames per second. Additionally, they're not variable frames per second. Whereas when you're using FrameGen technology, you might often be running at variable frame rates and oftentimes well in excess of 60 frames per second. So in order to capture this footage, they had to capture 120 FPS footage and then reduce it to 50% speed at 60 frames per second so that we can actually see every frame. That has the effect of making it easier to spot artifacts, which actually makes this test a little bit unfair, because if you were then instead actually watching this at full speed in person, anytime you had an artifact on screen, it would only be visible for half the amount of time that we see in this YouTube video. That's why it's so challenging to try to spot these things. So this is actually going to make it look worse because we can see every frame twice as long. So any issues will be accentuated. The other issue is this is also was having to limit it to 120 FPS to capture the footage, which means if you're in like a ×4 mode frame gen, I think you're actually at a fairly low actual base frame rate, if that makes sense, before the extra frames are introduced. Whereas ideally, you'd actually be using this on a higher refresh rate display, maybe 240 hertz, maybe 360 hertz, right? Where I think that kind of multiple frame gens will be at its best. Because then again, like I said, each individual potential artifact in the frame will be visible for a shorter amount of time, and the original frames that are rendered without artifacts are going to be closer together, so there's less guesswork at what happens in between. So basically what I'm trying to say is the footage we're looking at here, you have to understand, is actually probably a fairly worst case scenario as far as making it look worse than it potentially would in person. That being said, when watching the footage on my own screen, I absolutely noticed a lot of issues in panning and motion. It's the kind of thing that bugs me with DLSS 3 sometimes, why I sometimes turn it off in games. For example, if we look at this this gun sign right here, this neon lights. Now, if this is super small on your screen, if you're watching on a phone, you can pinch to zoom in the YouTube app. Not everybody knows that. Anyway, if we watch this as it pans sideways, you'll notice that this kind of, it looks like kind of jumpy and artifacty in motion, which again, it's not going to look as bad in person. And you can go to the original source file because there's also going to be additional corruption because I'm capturing this and then you're watching me record their capture, and then there's additional YouTube compression. So I'd really recommend you go and look at this. Honestly, go ahead and look at this on your own screen from their original source. And they even offer higher quality versions for their Patreon and whatnot. Now in scenes like this, I'm not seeing a ton of issues when it's walking straight in motion, but when it's panning side to side, I'm seeing a lot of issues. Like when you look over at this stuff, this kind of just looks shaky side to side. Here I'm noticing it a bunch on this tree and window stuff right here. It looks a little shaky side to side. Again, go back and maybe look at the original source material when you watch that. I might go back and show it again right here, but this, again, things just look shaky. So to me, that's a little bit concerning. However, there's also, like I said, the fact that this is the worst case scenario. We're watching this at 50% speed. It's capped to a maximum of 120 FPS output as opposed to being allowed to run at a much higher frame rate. So to kind of wrap this up, my overall thoughts based on all the information we have so far about this new DLSS 4 multi-frame gen is, well, it seems to definitely do some things better than DLSS 3 frame gen, right? You're gonna get a lot more of that motion fluidity than even the DLSS 3 frame generation got you, and it doesn't look like a massive decrease in responsiveness. But I am still a little bit concerned about having that many extra generated frames compared to each 2 real frame having too many added artifacts. I'm definitely seeing some issues related to that in Digital Foundry's footage, but like I said, worst case scenario. So I'm hoping in person that I'll be a lot more impressed by it. But in general, I think this is pointing to the fact that, again, gonna blind you, I'm a little concerned about the default of just using frames per second as our way of measuring GPUs. It was nice for a long time because all the frames were of equal quality if you ran the game at equal settings. They all looked the same. And an increase to frames per second made the game more responsive and more visually fluid. It was a great way of capturing everything you wanted as far as making a game run better on better hardware. Whereas now we're living in this world of not all the frames look equally good, so just counting them doesn't really, and putting it in a bar graph doesn't really tell you that, right? And then also, generated frames, like I said, they're increasing motion fluidity, but actually slightly decreasing the responsiveness. But by how much? And what are the added artifacts and all of that? So GPU reviewing is getting extremely complicated because it used to just be bigger number, better, look at the bar graphs, compare that to the price of the GPU, which one offers better value. We're just not in that world anymore. And I think that a lot of people like these technologies like this new frame generation. And I think a lot of people are going to absolutely love this. But how do you give an objective answer to how good it is? That as a GPU reviewer, that's really starting to kind of bother me, right? Because I can give a lot of subjective thoughts on it, and you can try to capture some numbers and some numbers for latency, but like, are some people going to notice an extra 6 milliseconds of latency? Probably. Are a lot of people not going to notice? Probably. Can I subjectively try to tell you how it feels for me? Yeah. What is it going to feel like for you? I don't know, right? So that's where this is getting really difficult. The last thing I want to leave you with is the fact that DLSS 4 multi-frame generation is what I focused on in this video. And, but I do want to remind you that there's also an update to the underlying DLSS model. So the underlying DLSS model is being enhanced for just the normal super resolution, not just the frame generation, as well as ray reconstruction and DLAA. And all of those enhancements are going to be available to all RTX 20, 30, and 40 and 50 series GPUs. And that's that new transformer model, moving beyond the CNNs. NVIDIA's made a lot of big claims about the potential image quality for this. They've shown a lot of clips showing things that previous model often struggled with, things like chain link fences and things like that. And in their footage, it does look significantly better. Chain link fences were a problem. The ghosting, where it kind of leaves that after image on the fan, that's cleaned up a lot in this model. And we're also seeing, I think they show power lines a lot better, a lot less flickery than what we see here, much more temporal stability. They're showing other games like here in Horizon Forbidden West with just reconstructing a lot more detail on that backpack. So there's a lot of good stuff here. And I'll also say that the Digital Foundry video looking at the DLSS 4 also looked at the super resolution. And that is where I think that it is, and this is one of the things that's easier to look at, because you can actually just side-by-side look at it. There's not all those caveats on how you capture it and the motion fluidity and all that. And I will say it does look like in their side-by-side comparisons that there is a significant increase to the the model. Like, it does end up solving a lot of those problems. So like they captured like the edge of this door in the new model versus the old model, looking a lot sharper. They did show examples of ghosting improvements and all of that. And again, I recommend you take a look at the whole Digital Foundry video. So overall thoughts here is I love that this underlying super resolution model does appear to be better, although I want to see it tested in more games and more thoroughly. And I do like the improvements to the frame generation technology, but I just still have some questions about the multi-frame generation in person. Are those artifacts going to bother me? And the bigger underlying questions about GPU reviews in general, because NVIDIA is really pushing this towards, we're not just traditionally rendering things. There's a lot of AI. There's a lot of frame generation. There's a lot of super resolution. And those are all cool features for the end user, but it's extremely difficult to handle as a GPU reviewer. Hopefully this video helped shed some light on all that kind of stuff. And stay tuned for all my other thoughts on upcoming GPU launches, any other cool information from CES and all of that. I hope all of you have an excellent day.